Okay, let's take a look at these couple here, 25 and 26, which are geometric, very geometric, okay? In fact, we're talking about uh, the rectangle here, okay? And the rectangle and its dimensions are, let's just start off by constructing it. Okay, so it's a rectangular piece of land, uh, 583.6 feet by 427.5 feet. Find the smaller of the two acute angles made by a diagonal of the rectangle. Okay, what is the length of the diagonal? Okay, well, here's the diagonal, right? Okay, um, this length is the same down here, 583.6. Okay, um, I'll find the angle here, A, and once I have A, of course, I'll know B, and I'll know which is larger, all right? That looks like tangent, okay? So the tangent of A is 427.5 over 583.6, okay? So again, that's actually, we're looking for the angle, so I'll have to use inverse tan and just pull up the calculator and get this, do that number crunching right now. So that's, what I'm first going to do is I'm actually just going to find that decimal value. So that decimal value, 427.5 divided by 583.6, okay? So that decimal value is 0.7325, 0.7325, okay? So I have that the tangent of the angle A is 0.7325. So I want A. A is going to be, okay, the inverse tangent of 0.7325. So let's go back and find that, okay? And so I'm going to ask for the inverse tangent, okay, which is a diamond function of this value, and I could just go up to my calculator and grab it right there and then enter that. I forgot a parenthesis, okay, it's going to tell me that, all right, and that looks like 36 degrees. So that is the smaller of the two, obviously, okay, A is equal to 36, and so if A is equal to 36. We certainly know the other one, which is 54. Okay, so this is 36. This is 54. Of course, we knew that because we knew that the smallest angle is opposite the smaller side, right? And now the only thing, what is the length of the diagonal? Well, two ways. Of course, we could use Pythagoras and find the diagonal. Or with both of these sides, you could either use sine or cosine to find the angle. I'll leave that up to you to find that, okay? Let's look at 26, okay? 26, the length of the base of an isosceles triangle. Here's our isosceles triangle. Here's our base, because we're going to call these our base angles. And we're going to say that the base is 42.54, okay? We're going to say that the base angles are 39.27. And what are we asked to find? Find the length of each of the two equal sides. So here we go. Okay. We're going to split that in half. And splitting that in half. Okay, where'd it go? Here we go. Okay. We want to find the lengths of these sides. Okay. Well, 42.5 is this entire base, okay? We're going to cut that in half, okay? So if we cut that in half, we're looking at 21.27. The angle hasn't changed. That's 39.27. And we're after this x, which is the hypotenuse. That looks like a cosine to me, okay? So helps to draw the diagram to get a better idea of what it is. So we're going with the cosine of 39.27 is equal to the adjacent 21.27 over x, and I'm sure you can figure that out from there. Just one more thing to mention, okay, and that is a problem up here in number 22. They said 35 degrees and 20 what? Well, okay, whenever we're talking about something less than 1 degree, if this is 1 degree, I know it's very large for 1 degree, but it's 1 degree. It's also, when we're talking about things less than 1 degree, we start talking about what we call minutes of arc. So 60 minutes, and that's this single slash, is equal to 1 degree. So this is 20 minutes, which means it's a third degree. So then the angle which they're talking about there is 35, okay, and 1/3 degree. You can just use that. These indications of minutes are for distances very far away, okay, planetary minutes, planetary distances, okay, in which case they even take 1 minute and they break that down into seconds, okay, but don't worry about that too much. Just remember this then is 35 and 1/3 degrees. Okay, so you should be comfortable with those. Get them done, and get ready for our quiz for tomorrow.